Being recorded.
All right, so this is the first of what should be many kind of office hours for the Garage Cloud Native Toolkit assets. So we're going to start with Terraform, kind of where we started with a lot of the projects. So we'll do kind of an overview of Terraform and the structure, and then we'll dive into the components that we have and look at all of that. So just to set a little context, let me share my screen.
Is the meeting being recorded, Sean? Sorry.
It is. Yes, it's being recorded. So just to kind of terraform this idea of, instead of using a proprietary tool to provision Azure, or I know AWS has their CloudFormation tool, but it's very specific to that platform. Terraform provides a cross, multi-cloud approach to provisioning, and it really can be beyond cloud, but primarily it's through providers that you get access to the different clouds. So a provider in Terraform is essentially a wrapper for some API. For the most part, we're talking about cloud providers. Now, unfortunately, I think it's because of some legal issues with between IBM and HashiCorp. IBM is not listed as a first-tier cloud provider. We end up getting lumped in this other ISV provider group. I think from what Matt and I were talking about, part of it's because we have schematics and we're a little bit of a competitor. We're selling their own stuff, and so that it doesn't work out well. So, but it doesn't preclude us from using it. It just means that if you go looking for providers, we get kind of lumped way down on the list. And if you go looking for modules, which we'll talk about in a minute, I think there's one IBM module, and there are a bunch of modules for other platforms. That works out when we're installing OpenShift on top of AWS, because there's a lot of features there. It's just, so we ended up building our own modules. We have not published them to the Terraform module registry yet, but they can be used all the same. So it's this idea of infrastructure as code. Everything can be configured and the desired state defined in Git. One of the things we want to make sure we do a better job at is true Git ops with Terraform, because it can be done that way. The provisioning is through config and templates. There's a nice abstraction layer, and then you can do the provisioning out to whatever target you go to. Now, one thing I just we have moved, we're kind of in transition. So I'm going to be talking about Terraform 0.12 because it's actually, they've made a lot of improvements, and we were delayed in being able to adopt it because the IBM Cloud Terraform provider only recently supported it. So we'll go through. So if you go look at master branch right now, it's still using version 11. The pre-release of 4.3, which by the end of this week will be a full release, is all using Terraform 12. So that's what we're going to be talking about. So just a couple of things, what they've done in 12, and like I said, after this we'll dive into the code. But they made, so HashiCorp Terraform, they have their own language, HCL. They've improved it. You'll find it's fairly straightforward, but they've made it a lot cleaner. And if you're using something like IntelliJ, it does a lot of the code assist and validation for you, so it makes it a lot easier to write these and not have to wait until you execute it to do some of the validation. But it does support. Previously, everything had to be done through kind of these templated strings. Now you can just reference that string now you can just reference that string directly or that variable directly without having to wrap everything. And it supports a richer set of types now. Well, let me start here. So the richer set of expressions that can be used. You can use the splat operator for if there's multiples of a thing, and we'll talk through that in a second. For loops they support now. So a lot of the language has gotten better, and it's easier to do. So we had to jump through some hoops in 11. So with 12, we were able to clean up a lot of stuff, and there's still work to be done there. But and you can, so it's possible, and we do this in a couple places. If you want to create, say, multiple copies of the same resource, you can use this count function that says I want 4 of these, and you can change the values for each one. But that creates these resources, and there's multiple of them. You can access them by index, or you can use the splat operator to get, I want every address. If I created 4 namespaces, I can reference each of those blocks and get to them. Let me just flip through some of this. So there is a support for rich data types. Before, it was basically everything was a string or a list of strings, and that was it. Now there's primitive types are supported and complex types as well. This is one where we haven't used a lot of this yet, but we'll move into that. And it does support native JSON out of the box. So it's kind of a hybrid language, but JSON is supported natively. So the other part, I mentioned there's a set of providers. A provider gives you function for accessing a particular resource. So there is a GitHub one you can use to modify Git resources, Git repos. AWS and Azure and IBM, the IBM provider as well. We'll spend a lot of time going through the IBM provider here. So what does this look like? I'll start with the modules. So Terraform, you have providers, but then you can organize logic in modules. A module is just an encapsulation of a set of logic. And so if we can we're going to look at one. We've created several modules as a way of encapsulating logic, be able to combine different pieces of logic, and that gives us some of the variability that we look for. We can plug one in and replace it with another, and so that's done through a module. And so module is basically there's 3 parts. There's variables; those are the inputs to the module. So what are the required input fields to be able to use that logic? And you can default some of those values, so they don't all have to be required. Every value has to be, every variable has to have a value, but it can be a default value. So it's just a block variable, a type. I think there's a number. Most all these are strings here. A description for what's the purpose, and then you can have a default. So this is our module that provisions the cluster in IBM Cloud using the IBM Cloud provider. So we have defaulted, there's some things it needs like the machine type. So we've defaulted that. We've defaulted the number of worker nodes, but any of these can be provided and overridden. Whether it's shared or dedicated hardware, right? All of these are input to that provider. Some of these are defaulted, some of them are not, which means they must be provided when this module is executed, and I'll show that in a minute. But so there's a set of variables. So these can be anything, and as I said, that it supports richer types now. So you can have a map as your input, which is a structure, a more complex structure. So far, as I said, we've done everything pretty flat. We might start combining some of these into more complex objects to make it more straightforward, especially things like the VLAN IDs that are related. That should be part of, it's a tuple really of of a set of values. So then another piece is the outputs, if any, right? This is not required, and neither of these are required. If your module has no inputs, you don't have to have variables. If it has no outputs, it doesn't have to have, you don't have to have this file either. But if there are things that are done in your module that you want to export so that other components, other modules can use, you make them outputs. So it's a similar thing. It's a value, and this references something that's in the main.tf. This var is referencing one of the variables that are defined in the variables tf. And then this local is referencing something defined in main. So you can hard code values, and I think there may be one case. Well, so you can, and not one in here, but you can hard code values in here. The description is there. You can also, this depends on, and we'll look at this more in the main, but depends on says there's an explicit dependency on this output with this activity. So don't export this value until this thing completes. So Terraform will work out implicit dependencies if, so say in this case, the depends on isn't absolutely necessary. Well, in this case, this is a different activity than what produced it. But if you want to, if you're saying, I want to export this value from this activity, Terraform will automatically work out, hey, there's a dependency. I can't export that until it's available. But you can also do these implicit dependencies to say, hey, I want to wait. So in this case, what we're doing is essentially not exporting these resources until the cluster is ready. And then downstream modules can start doing things against the cluster. So that's why these dependencies are here. But you can define a set of variables. We try in the modules to limit dependencies as much as possible, but as you can probably imagine, the cluster is a core dependency of most every downstream module. So we have set up the cluster, and then we export these values, and they're referenced by everything else. And then the main is where you put your logic. Now, there's a couple of constructs in here. There's, if there are Terraform providers, you can reference them and configure them. This is not absolutely necessary unless, like in this one, we're configuring the Helm provider to say this is how you connect to the Kubernetes cluster. So that's going to be needed. But this one is not absolutely necessary. It prevents a warning message by saying this is the version we're using. And since the IBM provider is not a first-class provider, it has to be available at the time the Terraform runs. When for these others, Helm, Null, and Local, I'm talking about what those are in a second, but since those are first-class providers, when you run the script, Terraform will pull those down automatically. So that's what you can say, this is the version I need, and guarantee the version. At this point, we're just saying whichever, grab the latest. So we're using in this module for providers. One of the things we kind of got into when we were building them is got a little bit too much into using, like dropping down into the shell and using the shell maybe more than we should. And that's this null provider is how you do that. Trying to refactor this to be more Terraform native so that we have fewer external dependencies. So what the Helm provider, as you might imagine, executes a Helm chart. The null provider lets you drop into a shell, do null resource. Local lets you work with the local file system, read files. And then the IBM provider, as you'd imagine, is the accesses the IBM APIs. So the other thing that is important to note, there are two other major constructs or two major concepts in Terraform. That is data or resource. And it took me a while to figure this out because if you look at this, if you look at the IBM Cloud Terraform provider, they don't do a great job of distinguishing it. There's a lot of great documentation. This is that's not the right one I want. Oh, they moved it.
So, quick question: these providers all written in Go? Is that primarily the
they're all
language
written
they're
in
written
Go.
in? Okay.
So that's the other option. Is in some of the cases where a provider is not a provider available to do what we need, we might create a custom provider. We haven't done that yet. We've just been using the shell. But yeah, they're all written in Go. So they have okay. So you see here, they just rebuilt this documentation site. But so they've got things organized. As you can see, let me find cluster. Okay, I'll just look at these here. So there's cloud infrastructure resources and cloud infrastructure data sources. So a resource is used to create something. So this block of code is creating the CDN with these parameters. A data source is something that retrieves. Actually, I had an example back to back of the same thing. They rehosted this. So here's in this one, this is referring to an existing resource group because it says data. So it's going to expect your group to exist, and it's going to go pull down whatever details it finds for that. One of the biggest one is the ID, because there are places where you need the ID of the resource group, not just the name. So this, because it says data, it's going out and attaching, it's going to find that resource group and bring out the details. So then later you can do data.ibmresourcegroup.group.id and reference it like here, reference it in the, in this case, it's creating a database. This is an etcd database because it's a service name. So it's provisioning a database in this resource group. So it needed to do the lookup with the data to be able to get the ID to pass in. So that's a big distinction as you look through here, right, between data and resource. And the other thing that's a little quirky is later when you reference them, if you want to reference this thing, you have to prefix it with data. So it'd be data.ibmresourcegroup.resource group. If you want to reference the resource later, you just do null resource dot IBM Cloud Login. I'll come back to that block up there for locals. Well, I guess, so locals allows you to define local variables. You can refer to other variables. You can do logic in there. And so it's this, you can refer to external variables, and I was putting these in here just to shorten that reference. So it's just local.server URL instead of having to go hunt for that value. So you can do, and in this case, you see this is, you can put a lot more complex logic in there. This is looping through all the versions and attaching OpenShift to the end because it needs it when you go provision. So you can,
so
you can put some logic in there.
I'm sorry to interrupt you. So where's that var reference that some of those variables you have? So I understand the data. Where's the var?
Yeah, anything that's a var is pulling values from this variable's TF. Let me move this right.
Okay, so that's the input variables?
Yeah, for this module. When we go up a level, there's another variables thing, but think about it, and that's why I started with modules, because think about it in isolation. So anytime there's a var reference, it's pointing to something out here, cluster type, right? And this is where it's nice with like IntelliJ. I think you could do the same with VS Code, but IntelliJ is doing type checking. So if that isn't called cluster type, you see I get a big red error everywhere that, hey, that variable doesn't exist. So it's looking at the variables defined here. Now, again, you don't have to split these all out. This is a convention. All those variables could be defined in the main, but the way when you these can be published to the module directory, and what it'll do is it looks for variables and it creates a nice formatted page for your variables. It takes the description and everything. Same thing for output. So that's why they want to keep them separate.
The thing that I want to try and understand is the scope. So you're saying this variables file lives within the scope of that module.
Right.
But when you start joining modules together, do they become like globally scoped, or are they module scoped?
No, these variables at this level are always module scoped, which is why there's another variables file at the outer level, right? There's different layers of variables, but so this is always scoped to this level, and you have to pass in when you invoke this module. You have to pass in each of these variables to the module. So I'll make sure I cover. Remind me when we get to the next level up. I'll try to make sure I cover it. But if I don't cover it enough, we'll talk about it again. But these are scoped just at the module. So at the module level, nothing exists outside of this, right? This is all self-contained. You don't assume anything else, right? So any var reference here absolutely has to be defined here in this variables file.
So if we're adding a new tool, so let's say I'm adding the Swagger editor, then I would create a module, and I have to make everything within that module self-contained, the inputs and the outputs completely. I can't assume. So how do you, let's say, hopefully when you get further on, you'll explain then, for instance, where's the cluster that I'm going to put it in? Is that done at the next level up? Is that the way it's going to happen?
That's getting passed in. Well, so here, that one. Let's say the the dashboard is fairly straightforward. So in the dashboard, it's this cluster config file that points to, like, this is the configuration that has the cluster in it, this is the file that has the cluster definition in it. It ends up being /kube/config.
Right, but that strikes me as that has a dependency then. That module has a dependency on that input. Because where does that cluster config file come from?
Well, yeah, so somebody's got to provide it in. All these modules, somebody has to invoke them, right? Think of these as it's a set of logic, there's an input, right? So that has to be provided, and that's at the next level up.
How do you test them then? How do you test them?
Sean,
you show. So typically, yeah.
Just a quick question that you have side by side. So in the main.tf, you access a variable by var dot. What is data dot?
So data dot is referring to one of these structures within the main TF. So let me walk through the logic of this, and then we'll come.
Yeah,
show
you
you
come to cover it. Yeah.
Yeah.
Okay.
So that's where data dot is one of the resources from the provider typically, or it's a resource from a provider. So it may be, in this case, this is data coming from, like this one, data container cluster config. That is from this one, right? So it's referring to values that are output from this. Now, they just changed this documentation, and so far I'm finding it harder to navigate than the old one, because
So, quick question on that: has the original Terraform provider docs now moved from the GitHub repo link, and they've now put it in the IBM docs? Is that what's happening?
Yeah, that just happened today, because it wasn't like this yesterday. They put them in the
cloud release is on a Thursday, so they've obviously pushed the release out today.
But I'm not seeing the cluster resources. So anyway, just to show, it doesn't matter at this point. So like this new cloud database data source. So when it's defined, each of these are similar to the modules. There's input parameters and then there's output values that you can reference. So after you run this cloud, so since this is a data source, IBM database, this is connecting to an existing service, a database service that has this name in US East. And so, and you know, you can put the resource group ID, it's optional. So it will connect to that database, and then now you can get information about that database, that service, from that data source. So you'd say, in this case, it's data IBM database.database.id, gives you a unique identifier. .plan tells you what the plan is. .location tells you if it's, you know, which region. Status, whether it's active or not. Right. So that's Carlos, when you're referencing data, you're referencing one of these, and that's the difference there between data and resource. Data refers to something that should already exist, and if it doesn't, it'll fail, right? If you run this before it exists, it will give you an error. Resource is expected to create something. So in this case, so this is the cluster module, right? This resource is where we create the cluster because it's IBM container cluster. And there should be, if we went to the documentation, I don't see it, it's not obvious, but it should be defined in there. Say these are the values that are required. And then there are some data that comes as output from this. Now, one thing we're doing, because of the way we've set it up, right, we let you attach to an existing cluster. So if cluster exists true, and this is one we probably should convert to a Boolean now that it exists, but it's still a string. So if cluster exists true, then we set the count to 0, which means we're not going to execute this resource. It's not going to do anything. Or if it's not true.
So cluster exists. Cluster exists is one of those variables we set right up in the settings, right at the top level when we run this, right?
Right. But it has to get passed through a couple times. So there's a cluster exists here as well, right? So we're actually testing the value of this cluster exists now. It's a couple values removed where we set it in when we run the Terraform. So again, when you're talking about the module, you don't really care how it got there. You just say, I need this value, and it must be there because it doesn't have a default. It must have been provided for this thing to run, and so I will use the value. And it's at the next level up where you make sure it gets in there. So for right now, we're just saying cluster exists, it's true or false, and we're using the count. So this is a little trick because there is no conditional otherwise in Terraform. There's now a for each where you can be a little smarter about if you want to do multiple, but if you want to either run it or not run it, then you do this count conditional. It may be a little bit outside of what Terraform wants you to do, but because Terraform...
That feels like a hack. So what you're saying is if count is 0, then don't do it. That's basically
don't run it. Yeah.
Right, okay.
Yeah. I mean, the alternative would be to have a completely different module and change out the modules. But so much of the logic would be duplicated that it was easier and more straightforward to do this because all the rest is the same. Right? What we could have said is if cluster exists true, then use the existing cluster module. Cluster exists false, use the create cluster module. But so we could have done it at a higher level where we switched them out. But like I said, 90% of the logic would be duplicated at that point. So this was simpler. So it either runs or doesn't, and then we attach.
Like a skip.
What's that?
Essentially, it's a no op skip.
Right.
One module and it's just skipping over.
It's not going to execute that resource if it's set to 0 because there's no count. But you can still depend on it. So if it was 0, it'll immediately jump to this next one. If it was 1, then it'll wait until that's completed to do this next step. So this next step here is data IBM container cluster config, it attaches to a running cluster. So we create it, possibly, and then we go attach to it to get some information out of it. And so that's where all these references up here are. We want to get the ingress hostname from it. We want to get the ingress secret from it. We want to get the public URL from it. There's a private URL as well. We aren't tracking that right now, but we might want to. So we connect to the cluster and get all that information out of it. And then for whatever reason, this is, I think, want to put some pull requests or some issues on the provider to make some of this a little more straightforward. But we also need to get the cluster config for the cluster. It doesn't come in this config, so we have to run this as well. So this gives us the, it pulls down the cluster config. It's only really needed for IKS, but we do it for both. And that's that config YAML file that has, you know, here's the URL, here's the certificate, in all of that for the cluster. So we do this as well. It depends on create cluster. I don't know that we actually need that one anymore. And then it retrieves so we retrieve the cluster config file path out of that. And it's only needed for Kubernetes. For OpenShift, it's a lot cleaner. So that's part of what we're doing as well with these modules, is normalizing the behavior across IKS, OpenShift 3.11 and OpenShift 4.3 now. So where there's quirks between them, we kind of encapsulate that in the module and don't expose that outside. And we try to do that with all the modules. So there's not a Kubernetes Argo CD module and a OpenShift Argo CD module. There's an Argo CD module, and you pass in the cluster type, and then we take care of the details underneath. So, so you see, there's some conditions where let's see, like the OC login. We just run an OC login with those parameters that sets up the environment, and now it's ready to go, because it behaves differently for the provider behaves differently for OpenShift. So, but this only happens.
So just a question on that then. Does this run a bit like a DevOps worker process? So when this runs, it's running in some kind of Linux shell, where the context is maintained as it runs through each one of the modules and each one of the stages. Is that kind of the assumption?
Right. And what Terraform is doing is it's keeping track of the state and it's writing it out. Now, the difference between maybe Terraform and what Argo does with managing state is Argo will go query the actual cluster to understand the state, and then if the desired state is out of sync with the actual state, it'll bring it into a line. What Terraform does is it keeps a running track of the state. So and then if you go do an apply again later, it'll compare what you're asking of Terraform and what it did previously and bring it into alignment. So that's one of the gotchas with Terraform, is if you're going to use Terraform to manage some of this stuff, you should use Terraform and not go manually make changes, because if you manually make changes and it causes an issue with the state, when you go to reapply, it might cause a problem. But at the layer we're talking about, it's not a big deal.
Where's the state saved?
Well, there's a choice of, it can be saved in local files, and then you could commit that to Git. It can be saved in any number of other places, like a database, or there's a bunch of different storage providers for state.
Okay. So is it either configure the Terraform at the time that you're running it to point to an S3 or some remote location, or by default it's just it's a local file, like a
right. But by default, it's in the file system, and so we had been just committing the state to the Git. Although
in our iteration in our cloud native toolkit, like the person.
Yeah, so the way that now a lot of times when we run it, we just blow away the state because we rerun it. And there was a problem with Terraform 11 where the destroy didn't completely work right, but that's fixed now. So the idea would be by default, you'd clone you'd have iteration 0, you'd run the script, and then when it's done running, you commit your workspace directory back to Git. And then if you want to make changes, you make sure you have the latest version of the state, and you just apply, put a new module or make changes to that module and do Terraform apply again, and it would see that the state was what things had changed since the last time you ran it, and it would apply just that change.
So today the user needs to use our GitHub repo as a template, right, and create and save it. I don't think we're that explicit, but I missed that point.
I mean, that's the idea, though. Is it's a template. In fact, we probably should make it a formal template. But that's the idea. Is that
it's a green button.
Yeah, I mean, when we talk about customizing your environment, that's part of what you're doing. You're saying, well, these are the modules I want. This is what I don't want. It sets up the workspace, and you apply it, and then you can save that state. So yeah, we need to call that out more explicitly.
I thought it was just 30 files when I was running it. Okay.
So quick question then on this one. We're not in some cases we're not really using Terraform for what Terraform was designed, i.e. So Terraform was about infrastructure state, and we're actually installing apps into a cluster. Can you talk a little bit about some of the gotchas around that?
Yeah, so, and we kind of did a little bit of hand waving. I think there's a line between apps and, application apps and infrastructure apps. So that we've said, well, infrastructure apps like Argo, we'll consider that to be part of the infrastructure. So it's we don't get too bad of shape installing those. Now we did get a little out of, like I was saying, a little overboard on dropping into the shell. So that's what this null resource local exec is dropping into the shell. You can run a script. So there's a Helm chart, a Helm repository. So I'm starting to convert some of these things over. Instead of executing Helm from the command line, using the Helm provider to do that, right? And it's a little cleaner where you can, so this is setting up that IBM Cloud config map and secret in the cluster. So you set the values, instead that was kind of buried in the shell. This is a little nicer. The problem is that provider doesn't have, there's no Helm remove. So, and again, it's a little bit of the way Terraform kind of expects it to work is you're going to a clean install, you're going to put it in there. But since we've got this existing cluster notion, I ended up just creating a shell to do an uninstall first, and then an install. So
are operators easier to install then through this method than Helm charts?
Well, not necessarily. So here's the other frustration. There's a Kubernetes provider but it does not support custom resources, which is kind of a deal breaker. It also does not support doing an apply, right, where you have the resources defined in a separate YAML file and just doing an apply. There is a kube control
provider,
but it's not quite it's not quite as supported, right? So I've been hesitant to go use this one. It's a little dated, right? And it's
so this could be a gap. We feed back to our Terraform provider team and say, look, can you help us fix this? So we can apply CRDs very easily, right?
The Kubernetes provider works well, and if it supported CRDs, then that would be good. But the way it works, like if you want an ingress, you'd say resource, Kubernetes ingress, whatever you want to call it. You're basically defining the YAML here, but in Terraform HCL, right? I mean, it matches exactly what the YAML file would look like. Here's a spec, you got a backend, you got a rule, you got a path, right? So this works well if you know exactly what you're creating. But if it's, if you're getting a YAML file from somebody else, and that has all the content and you want to apply it, then this doesn't really work. And so that's where we're doing dropping to the shell, which I think you're going to have to do in some cases. We just need to be more judicious about when we do that. And we got into using NPM and getting away from, not using NPM and finding better ways to do it. So like this works well for Helm. But like I said, I had to drop into the shell to remove the Helm chart before we apply it, which I think is okay.
Yeah. One thing that to consider, I know this is being recorded, people watch it, but one thing that I want to experiment and then do a POC is draw a line for Terraform, where Terraform is used for the infrastructure of the cloud resources, because there's no better way but just to create the cluster, VLANs, VMs, AM resources. But when you have an existing cluster or the cluster is already created, then jump into GitOps, right? Where maybe a Terraform step does a kubectl apply of the Argo operator as a seed, as a bootstrap. And then after that, anything else that needs to go install in the cluster, we do Argo CD, create an application, and point to the Git repo that has the things that you want to configure. Like if you want to install SonarQube, then that way, if we want to tweak a setting on SonarQube or Jenkins or Tekton or Service Mesh or Knative, then we go to the YAML file, change something there, and then Argo would just reconfigure that operator CR, and then to uninstall, basically you just remove the applications, and Argo should remove it from the cluster if you want to clean up. That way, Terraform is a distinct line of Terraform is to install the infrastructure, and the seed of Argo or GitOps operator, that then the things that go inside the cluster, they live in YAML, right? They just live in a
And I agree on that pattern, but it's definitely not a novice entry point pattern, is it? That's an experienced administration pattern, I definitely feel.
Yeah, but at the same time, I don't know that Terraform is novice either. So, just a couple of things there. You said GitOps. You really mean Argo GitOps. You can do Terraform GitOps, right? But I think Terraform is not the best way to go installing those tools. Using Argo to create the, and we can have the Terraform install Argo, set up the seed repo, and then it goes from there.
Yeah. So the interaction for the novice will be go to Git and then change one line of YAML, right? Maybe that's the novice for the admin. The developer just does develop. It doesn't do this type of stuff. But that opens the door for a more scalable system, where if we bring things like multi-cloud manager, right, for example, then you can switch out Argo with multi-cloud manager, and then the YAMLs reside in that GitHub repo, and then you can have multi-cloud manager configure the second, the third, the fourth, the fifth cluster using the YAML files that are sitting in that YAML directory, or you just configure folders for dev, prod, staging, but it's the same workflow. There's no Terraform to upscale that, right?
Right. Well, again, I want to be careful because I think you're right, and the part about the YAML and the multi-cloud manager I think is good, but at the same time, when we talk about GitOps, it's broad. So, like I said, you can do Terraform. I think the principle of if you want to make a change, go to Git, change a value, and then have it reflected in the environment is the approach. But the tool doesn't have to be Argo to do that. So I want to make
that's what I'm trying to say. Yeah. When you go to MCM,
it could be Terraform that does that. So I just want to.
And it could be MCM also.
Yes. Yeah. But I want to make sure I think what you're saying is correct. I just don't want to confuse the two of, in order to do GitOps, you have to do Argo.
No. So that's why I was very careful to say the system with this operation or syncing operation, right? Of being in Argo, it could be Argo, it could be Flux, right? We can just decide to use Flux or not.
Or it could be Terraform.
MCM has subscription and channels, but the thing is the Terraform files can live in Git, but then we need something that kicks when we change the YAML files in Terraform in the Git repo. It needs to be a Git webhook, a Tecton that does a cron job, something that runs Terraform.
Right, and that's possible to do. We just hadn't set that up. I think there's two parts to that, right? Having the Terraform operate in a GitOps, being structured such that it operates as a GitOps mechanism where if you change the config, it gets applied and synchronized. So there's some infrastructure there. Like HashiCorp it'll do that for you in their enterprise model, but having a different model.
One of the things we've got to work with is schematics isn't quite built for GitOps, and nor is our Cloud Pak installations. They're very much fire and forget and then uninstall. So yeah, there's some maturity. We've got to work around how all of that mechanics are going to work.
But the other part of perhaps these tools should all be done by Argo, or at least having an option to do that. That's certainly.
That's what I was trying to say. Yep.
Right. Yeah. So Argo gets
installed. To the Terraform files. Yep.
But the rest go through Argo, and there's a Git repo that does that.
Or like you said, don't say Argo. Those things go through.
They go through
a Git repo, YAML files, and then somebody applies
YAML or whatever. Right. Yeah.
Yep. It could be help customized plain YAML files, but they live in Git, and your options to put them in Git, the iteration 0 can help you, like create the Git repo, create the folder, push these files, right? Help you.
Right. And that's for I see that as scaled administration, because the operator hub doesn't work like that. The new marketplace won't work like that. So this is a pattern definitely for advanced administrators, definitely.
Well, I think it can't. I mean, you can use Operator Hub Operator Hub. The way that you work with operators is just through YAML too, right? So you can have Argo deploying operators.
Yep.
It's just a subscription document that you create.
It's like 4 lines of subscription. It's 4 lines of a subscription.yaml, and that's how I'm doing it.
I'm saying it can be done, but their entry point from a developer experience is not to start with a GitOps repo. That's what I'm trying to say.
Right.
You discover, use a UI to discover, search what you're looking for, select one of the databases and click there. And that clicking is creating a subscription.yaml and applying it.
Now, there is a way, I think, in OpenShift 4 to export or have it kind of, at least from what I saw, the office hours they had, where you can install it initially that way, right? The discovery, and it gets installed, but then you can like right-click and export, and it'll give you here's the YAML that was used to produce this. Now you go put that in your GitOps and.
Yeah, that's the follow-on story, because again, one of the objectives of this work was simplify the developer experience rather than focus on the advanced administrator experience. So yeah, it's that balancing act.
Yeah. So
I do it today, but not through the UI. I install, because I don't know what I went to install. I install Argo pipelines, Knative subscription, and then I go to the CLI, run a script, and I get back the CRs for the operators and the subscription for the operators, those 2 files, and save them in Git.
Right. So real quick, you'll see this is the app ID one. You see how clean this one is. It's all using the provider. It creates the instance.
Yeah, that's a good one for Terraform, yeah.
Creates the key, and then it binds. So this is one where we actually use the count correctly, right? So there's 4 namespaces we want to bind into. So we do, we go through 4 of them, and for each one we set the namespace to be namespaces index. Right. So we, instead of having this block over and over, so it's dynamic. You can pass in any number of resource groups, and it'll bind into them. And then if you change that later, you added to it and reapplied, it should just add to those new ones and leave the old ones alone. I mean, we have a version with this has all been turned off, but that used the, now this could probably use the Kubernetes provider if it allowed custom resources, but this used the operator to provision. Again, it's just creating a custom resource to do that. So in the time we have here, any questions about the modules at this point? Okay.
There's source control. You mentioned that the versioning and the dependencies.
Yeah, so we are versioning the modules. Now, right now, since it's all one big repo, they all get versioned together. The way that, part of the reason we haven't published any of our modules into the Terraform module registry is they want each module to be its own repo. And we've got, I don't know how many, 20? So there'll be 20 little repos, and we just don't have the bandwidth to manage those independently. So they get versioned all together, and we tag them. So when you reference a module, let's just go to this one here. You point to the Git repo. I mean, you can have when we started, the modules were in the same repo here, and it's just the directory, /module. But to be able to manage versions separately and to do all this, we pulled it out, and you can combine, you can reuse those, however. So you just point to the Git repo where it lives and the path to the file, and then the ref can either be a tag, so like v1.2.1, or it can be a branch. So the process for introducing new functionality, at least the way I normally do it, is I go in and branch the Terraform modules, make the changes I want to the module, and then I come in here and I point the stage to the branch so I can test, right? And this is just in my local version for a while. And if I want to share this so Matt can try it out or whatever, then I'll branch this. What's that?
Well, in the open source model, you don't have right access to the you don't have right access to the main repo. So if somebody's going to collaborate, they will need to change 2 things. Also the fork, point to their fork.
Yeah, they can change the whole path to point to their fork, right? Yeah, and so then you can test. So this is where the value here on the left has to match do I have it up here? It matches the variable name here.
Variable inputs.
Right, so this on the left are variable inputs. They have to match these names. And if there's a variable defined here that does not have a default and it is not defined here, Terraform is going to blow up the very first state. Because when you do Terraform, now we hide it in the, we normally do the script so you don't see it. But in the apply script, right, the first thing you do is Terraform init. That goes through and it validates the modules to make sure, okay, have you provided all the required attributes or required variables? Do the modules match? It does a syntax check at that point. So if you're trying to use this module and there's a variable that is required but you haven't provided, it's going to blow up. Also, if you provide a variable here that does not exist over here, it will blow up, right? So it does that validation check. Now at this level, anything that does var is referring to this variables. So this is a different variables file at this level. So they don't have to be the same name. They happen to be in these cases because we built them that way. But these names don't have to match.
Okay.
But it's at this level it's the variables defined here. And again, we've got defaults at this level as well in some cases. So this is where, there's people, oh, I don't want that. I don't want my namespace to be called tools. I want it to be whatever. This is where it could be changed, either the default or it can be provided in the Terraform variables. So I introduced this SRE namespace because I don't know if SRE is the right name, but LogDNA and Sysdig want to go into their own IBM Observe, and so we can change that if we want, but that's where they were going by default. So just to make it clear, that's there. And then release namespaces are the dev test staging. So if you wanted different names for these, you just change this value, and you get different names for the namespaces. Yeah. And so anything here refers to those variables. You can also refer to modules, so like namespace, and I mentioned there's dependencies between components. So the cluster type, we want to come from module dev cluster type. The config file path comes from the module because that's output, and these values are from the variables. There's another one. So SonarQube, right now, this is one next things we need to fix. Postgres is needed by SonarQube. So SonarQube is referring to the Postgres module to get the name, the credentials and everything, the location of the database. Yeah, these are the outputs. Yeah, these values are defined
the module is output
of right. So those outputs, you see, it's giving me a warning because I haven't updated this to the new syntax.
And that's what it triggers that it needs to run that module or not.
Well, that module will be run because it's all together, but it will wait because this module has a dependency on that variable from the other one. This one won't execute until Postgres is completed, right? Until it's ready. So that's part of. There's two reasons why the module dependencies are being used this way. One is because we want to pass data from the module, like the cluster module, from the Postgres module down to the next level. The other thing is to help Terraform with the sequencing, right? If SonarQube depends on the cluster and on Postgres, we can't install SonarQube until the cluster is ready and Postgres is ready. So that's how
the name of the files is just for our convenience, for readability. It doesn't mean that they're going to run in that order.
Right. Yeah, exactly.
It takes
could all be in one big file.
Files. It takes the whole thing. That's one that complete folder is doing the they need, and then doing a graph, right? A dependency graph of all of it, and then whatever it can run in parallel first, it will run and then wait for that, and then it will create the dependency graph.
Right. And it may even run. It may even run part of the module. So it'll start executing the module itself, and until it gets to the point where it needs that data, then it will wait until the data's there. So it'll start all the modules right away, and then when it gets to data that's not available, it'll wait until that data's there, and then it'll continue. So at one point in time, so the names of the stages is a bit historical. It helps logically organize them, but at one point in time, we ran it to where we would copy everything that was stage 1 and then apply that. And then we would copy in everything that was stage 2 and apply that, and then stage 3. So at one point in time, we were actually executing them in the way, all the stage 1, then all the stage, and part of that was because we had to, because there was some weirdness with Postgres and the way it worked and whatever, right? But it's cleaner to put them all together and let Terraform work it out and not do a multi-stage apply. It's also faster because there's a lot of overhead. Each time, like when we copied stage 2 in, we'd run a init and apply, it would go back and validate the state that it did during stage 1. Does it match what you're still asking? And then now let me add stage 2. So it's, that could still be done where it's done sequentially, but it's cleaner. The install goes cleaner if you just let Terraform work out the dependencies. And there's a way to generate that graph. There's a Terraform graph function that'll give you a nice diagram of here's all the modules, here's the dependencies. But what it means, though, too, with these stages, if you don't want to run a stage, if I don't want Pack Broker installed, you just remove it.
Remove it.
And then it's just not going to apply that. Right.
Something that people don't get first day, that they can remove files.
Right.
These files are consolidated.
And one of the things we're looking to do as part of the private catalog, but also just as a usability feature, is have a way to, because right now it's all just a shell script that's pretty dumb, that looks at the variables and sees, and we know from the script these are required, so let's prompt for them if they're not provided, and then copy it over. But have a smarter kind of wizard to say, hey, do you want, check the boxes for which features you want, and maybe if you pick one, it says, well, that one has a dependency on this other, so you have to have that. So maybe having a little more guidance on that without going overboard, but a little more guidance on, hey, you can pick, and if you don't want this, remove it. There's another thing, Roland mentioned Monday was being able to do more of a progressive install. Okay, day one, I only want this core set, and then 2 weeks later, I want to add Redis or Cloudant, and then 3 weeks later, I want to add Redis, right? And be able to progressively add.
And that's why I wanted to remove that from Terraform, because as you can see, you can deploy the cluster with this Terraform installation 0 and get maybe the minimum tools. And then once you do this, you go to the cluster, open the dashboard, and there's a button to add any of the 3 optionals, like log DNA, click log DNA, and then from the dashboard, we can initiate that install, right?
Yeah. See, I'd make log DNA and sysdig non-negotiable, right? Those get in, or whatever the equivalent would be. If you're on OpenShift on-prem, it would be the...
Or deploy with Jenkins, and I want to add Tecton. Right. How do I add Tecton?
Yeah.
Click the button, I Tecton, right? Or I install Artifactory, but I also want to use Nexus, so click Nexus.
Right. So if we did that through the dashboard, that's not... And then underneath covers, it's just going to Git, right? And,
CLI, yeah. Yep.
Or going to Argo and registering a new application, either way.
Yeah, runs a script or a cron job or a Tecton or something that is inside the cluster that has the credentials to do the thing, right? To go to GitHub, git clone, add the YAML files, git push, and then Argo picks up.
Right. And that works for the tools. For provision software, you'd still want to go to Terraform. But again, ideally, it should just be registering, make a change in the Git repo, and then it synchronizes and it applies the provisions of new service. That's why the operator was nice, right? If you could just say, hey, the operator's running. If I want a new service, I just add a YAML, and it'll provision it for me. It's just, it had a lot of downside too. So we'll see if we can get them to fix the problems. We'll revisit it, but I'm still a little leery of an operator that does work outside of the cluster. So one other thing here, just in the way this is structured, we ended up splitting out the variables that we use as input into environment TF-bars and VLAN, just because you only need VLAN if you're provisioning a new cluster. It's a little more complicated to get that, so we kind of hide that essentially. If you're just going to go against an existing cluster, you can go straight here and make the changes. Now, what run Terraform does is it ends up copying, combining those 2 files together into this terraform.tfvars. So this is a file that Terraform recognizes, and it will, any values in here, it will use to it'll populate the variables with them, right? So that's that last piece.
And this decision was about ease of use, right? Usability and entry point usability. That was the reason. Yeah.
Right. Yeah. But at the end of the day, this is Terraform TF-vars. So one thing I think we need to emphasize more, but when you do the run Terraform the first time, you get the workspace. At that point, you don't need to run Terraform again. If you want to change variables, you can go here and change Terraform TF-vars. You could add variables. I mean, you can make changes here in variables TF as well, but it's probably cleaner to work in this file. If you want to change the number of where is it? Yeah, the number of worker nodes, then you can change it here, or you can set it here, cluster worker node count, rerun it. And just from this directory, you could run apply again, and it would just bump up the number of worker nodes. You don't have to do anything else. So that's one of the things we need to emphasize more is, hey, once you've run Terraform, you don't have to run it again. You can, you can just work out of this directory.
How do I apply again? Just run apply.sh?
Yeah, you can run apply.sh again.
Or Terraform space apply.
Right.
Once you've got your workspace directory, it's effectively your state. So from there, you can make changes and reapply the state, or do a Terraform destroy. Right. So this workspace is the folder that you would typically put into Git.
Yeah.
So one of the thought processes is if we could guide a user to use the template to say, hey, pick and choose what you want, and then create this workspace, put it into Git, then you can do your Git ops and all your other management and things.
What about secrets? Any of the files has secrets or API keys or anything like that?
Not any of these. No. So we put those at this level.
This was your input, Carlos. We changed it because of you.
Yeah, I don't like to put my secrets in GitHub, by the way. Yeah.
No, we don't. So the secrets are held at the top level in a property file, and they're passed into the Docker image that runs Terraform.
Right. And they're in Git ignore.
Git ignore, yes. You read my mind, Steve.
Yeah.
Well, no, it was your input that made us change this design. So you influenced it.
So I have several copies so that I can switch between without having to go hunt.
Make it start. Yeah, because people would do the same thing, or us, right, to develop.
So, any other questions? We're a little over, but
This has been great. I knew zero of Terraform coming in, so I feel more confident now.
And I've ran this hundreds of times as a user. I haven't built the confidence to build a module, but you've demystified the variable scoping for me to try and add a couple of modules.
Well, I know Freddie's not on the call, but that was one of his frustrations, and one of mine early on too, is that especially when it was when all the modules were in the same directory, to add a variable, you got to add it 2 places, and I don't know but since they're separated, it makes it a little easier to see the difference. The modules are over here, the variables are here. Now, one of the things we've tried to do, and we want to continue as much as possible, is keep the inputs and outputs the same across modules that are the same type of module. So then they're more interchangeable, right? If the variables are the same, then they're interchangeable. So one of the things we've done, just here at the end, so this is the IBM Cloud cluster module. We also have the self-managed cluster module that we're using for CRC that Mike created, Mike Hefner. So one of the things he did, though, I had him keep the same outputs and the same variables. Even though some of these variables make no sense on CRC, they're just defaulted. They don't get used, and maybe we can do some work to clean some of these up. They don't get used in the main.tf, but they're here on the interface so that you could swap out the module and not have to change too much else, right? You could change this line, but the rest is pretty much consistent, right?
So could you see this being extended then to say, hey, I've got a Red Hat in VMware, I've got a Red Hat in AWS, I've got a Red Hat in AWS, and then this.
I don't know that it matters though at that point. I don't think where it lives matters so much, because all you have to provide is the server URL. You know, there's a couple, right? You just have to tell it where it lives, because that's all that this thing is doing, right? You see, there's very little logic in here. It's creating. I need to update this to use the Helm chart. So it's creating that config map so that we're consistent, but that's it. And then it's exporting the same values that we needed downstream. So we satisfied those downstream module dependencies, but all this is really doing is a shell to export the server URL, to export the, so it's more important that the outputs are consistent in this case.
I think my point was more on the create cluster module, is that you could create a common interface.
Yes, I think we could do that for the actual creation, the provision one. Now there are a bunch of scripts out there for OpenShift, AWS, and so if we can normalize all that so it's a similar interface, then yeah, you could go provision, VMware, AWS, or bare metal, or whatever, right? There's a bunch of different alternatives there.
We can create the Cloud Native Toolkit wrapper for AWS, and then use our interface, and then pass it whatever that Terraform needs, right?
Right. So I think there's some cleanup that can be done, because a lot of this was, when we created it, was all IBM Cloud. Like the config map is called IBM Cloud config. We probably should generalize that. So even the variables, some of these are here because IBM Cloud needed them, and even the IBM Cloud environment has gotten better where we don't need all of them. So we can get that down to the smallest common set, but that's the idea, is to make the modules as interchangeable as possible, and then also make the module know about the differences between Kubernetes and OpenShift. So you just drop it in, and it's a variable you pass that says, I'm running on OpenShift 4.3, or I'm running on Kubernetes. Work accordingly. Right? There's a route gets created now on 4.3. Ingress gets created on Kubernetes.
Have you tested this on a OpenShift 4 from the lab, like one of those OpenShift clusters with VMware?
No, the next piece is getting CRC on 4.3, and then after that, I want to point it to the lab. I talked to Noel yesterday. He gave me an overview of all of the scripts he's got for OpenShift and AWS and Azure and GCP, and he offered, to set up some an OpenShift on AWS to try this out, and OpenShift on Azure. So that's the next step. We
can try. We can try first the existing path on an existing cluster. Try the Cloud Native Toolkit.
Yeah. So moving towards more kind of Argo provision tools, I think is the next piece after we get 4.3 going. Any other questions on any of this?
Yeah, don't destroy the existing user journey. When you add Argo as an optional route to do install, don't destroy this journey.
Yeah,
because you're just putting more barriers to entry in front of teams. That's all.
Right. Yeah. So
we should keep consistent the experience. Yeah.
Yeah. The goal. Well, and for backwards compatibility too, that we would add new different modules, or.
I think my point is, not every administrator will start with a GitOps mentality. That's like trying to convince dev teams to use DevOps and engineering teams to build cloud native microservices. They're huge mountains of adoption to climb. So just don't block them out from day one.
Yeah, I think that's fair. But I think as a general philosophy, nothing gets removed, at least not until we have a clear consensus, hey, this is not necessary anymore. But adding a new feature, we're not going to remove the old. So the way the operators came to be, I left the old services, created the operator services as a separate thing. So the old were still there, and it worked out for us because when we went back, they were all still there and they just worked. So the operator's still there. If someone wants to be a pioneer and go out, they can still do the operator base. But so this is an alternative, right?
That comes back to your point that I've heard you say a few times. You don't have to use any of this, right?
Right.
You don't have to use any of the tools. You don't have to use Terraform. You can start from the catalog or a CLI and off you go. It's really about how your maturity point is of understanding how to get faster reward from the platform.
Right.
So, and I think that's the philosophy that all of this work should keep is you don't have to use a CLI, you don't have to use Argo. But let me tell you from experience, writing a CD pipeline in Tecton and Jenkins is not a trivial task. Have fun.
Right.
Tell us when you got it done.
Yeah, so we're giving you the option to make your life easier. If you find it doesn't make your life easier, then don't use it. Or maybe after you've beat your head against the wall a couple times, maybe come back around and try it out. One other thing I've heard, right, is, well, why Terraform, why Ansible? We picked Terraform partially because that's what we had when John Martin started. We had a bunch of Terraform scripts that he had written that we started from. Also because schematics is based on Terraform. So this gives us, I think maybe once it gets ready to GA, we will demo something that Matt has working of where you can package all of the workspace directory up and create a tile in a private catalog of so then you just push a button and it provisions all of this for you, right? So it gives us that synergy. But they just announced there is a Ansible plug provider for Terraform. So,
but it's a shell. It's like all of this. It's a shell over Ansible. But if you look at,
you could integrate your Terraform scripts and your Ansible scripts. If you got some things that were written in Ansible that you want to supplement what we have, it could be plugged in, and you don't throw that out.
Just on that point, GBS is differentiating Terraform for infrastructure, Ansible for configuration. That seems to be the dividing line between the two. You can, just like you can use a shell script to do installs, you can use Ansible to do infrastructure, and you can use Terraform to do config, but that seems to be where the line is separating. Right. And the reason my concern, Carlos, about let's put Argo in and then let's let Argo manage off Git, the way our current product is doing its installs doesn't work from a GitOps mentality. It works from give me a Git repo with the Terraform files and let me run it. And so we just have to duck and dive between where our product's at and where the maturity of consumption's at. That's why I'm being nervous that we don't throw the baby out with the bathwater in terms of what we've got.
I'm concerned about that, and also involved on the cloud packs being, this could be a Q2, it could be a Q3, right, where they are operators, but still run from one script, right? It's all the same. And the Ansible is also good to take into account. And that's the same feedback I heard from the outside, not just GBS, of that fine line of separation of using Terraform or CloudForms to deploy like the VM and the NICs and the infrastructure, and then Ansible to like configure the application inside, right? The Linux configuration or the system D stuff. Separation.
Yeah. Well, and I think based on what we talked about, Terraform has become a bit of a golden hammer for us. So I think there's some work to refactor this to maybe make sure that line is not crossed. Again, like you said, Matt, we're not going to delete anything, but start encouraging, hey, maybe there's another way to do it, and work out even where we are going to use, if we are going to use Terraform for deploying tools, cleaning this up so we're using the Helm provider and being more. The idea is to get, I meant that I don't know who I was talking to, but the image we're using to build is like up to 2 gig now, and the vanilla Terraform is 25 meg. So I'd like to get to the point where we pare this down to where we could use the vanilla Terraform image to run all of this. So,
to be fair, Sean, this is amazing work, and we've all been learning along this journey, and there isn't a perfect answer at this point in the world. So I think this has been amazing effort from some of the work you've done to modularize it, some of the work to abstract it. And I know it's not all perfect for everyone, but it's a huge step up from where it was just 6 months ago.
so we'll continue to turn the crank and work. So hopefully now all of you are ready to go off and start building modules and updating the ones that we have there. All right. So if there's nothing else, then I'll close it down, and we can we'll get. I don't know if we have schedule yet for next week, but and I don't know if we're going to do them every week, but certainly this is going to be a regular thing. I know we have Bobby teed up at some point soon to do the access control overview, and then we'll work on others as they come.